So this question has given us a shape that looks like it's got two triangles within it, and therefore it could be saying to us that this is going to be a similar triangle question. But let's have a read and see what they actually want us to do. So the first part of the question says, work out the area of the trapezium QRST. Area, again, the example would quite often give you a few formulas that could be used at the front of your exam paper. So we can see here that they do give us the formula for the area of the trapezium. So it's worth writing it down, and then we can start thinking whether we could use it straight away or whether we need to find other values. So the area of a trapezium is a half times the parallel sides added together times the height between them. Again, it's always worthwhile having the picture that's at the front of the exam paper in our minds. Then the parallel sides are the A and the B, and the H is the height between them. So A and the B parallel sides. So A is equal to 4 centimetres and B is equal to 12 centimetres. H equals the distance between the parallel sides, which in this case is equal to 10 centimetres. So we can get those values from the picture. So here's the parallel sides, and we know that's because they're telling us that that's a right angle and that's a right angle. So we can write the formula then. So area equals a half times the A value, which was 4, plus the B value, which was 12, times the distance between them, which was 10. So that becomes a half times 16, 12 plus 4 is 16, times 10. Half of 10 is, half of 16 is 8, and 8 times 10 is 80. And it's going to be 80 square centimetres because we're talking about area, so 80. So again, we got the information from the picture. We recognise that those two right angles are telling us that these are parallel, and therefore we've got a trapezium with parallel sides, and we can work out the area of it. Now, the next part of the question wants us to work out the length of PT, and we can see from this diagram then we've got PT here. Because these two sides are parallel, then we have similar shapes. So basically, because QT is parallel to SR, we have all corresponding angles the same in triangles QPT and RST. So these triangles are similar triangles. As soon as you've got similar triangles, because they're parallel, the corresponding angles are the same, and because they're similar triangles, then we need a scale factor. So we need a scale factor. And the reason for that is because we can see that the small triangle PTQ, and then we have the larger triangle PSR. We knew this was 4, we knew this was 12, so the scale factor is times by 3. So the scale factor is 12 divided by 4, which is 3. Now again, because we knew that TS was 10, then PS is going to be, so this is going to be X, so this is going to be 10 plus X. And literally we have a situation where we've got x times 3 is the same as 10 plus x. So 3x is equal to 10 plus x, so 2x is equal to 10, so x is equal to 5. So we find that the answer here is 5 centimetres. Basically, because similar triangles tells us that the scale factors between the corresponding lengths have to be identical. We found the scale factor by having two corresponding sides, 4 and 12 was times 3. So therefore the length of PT must also times by 3 to give us the length of PS. Well, we knew that PS is equal to the length of PT plus the length of TS. Well, that's x plus 10. And because we knew this was 3 times, we wrote down a little equation. So 3x is equal to 10 plus x, so 2x is 10 and x is 5. So that's how we got the answer of 5. So again, we see a shape that looks like it might be similar triangles. We can identify some facts. The right angles tell us that these are parallel. Therefore, we know that this angle is the same as this angle, and this is a common angle. So all corresponding angles are identical, and it's an enlargement of each other. The big triangle is an enlargement of the little triangle.